Hello students, now in our previous video we had already seen how to solve a problem using Picard's method. Now in this video we will solve one more problem. Okay, the question is solve by Picard's method up to fourth order of the IVP y dash plus y equal to e raised to x where y of 0 equal to 0. Now in this video, in this kind of problem, we need firstly, if it is Picard's method, that means we have the formula for dy by dx equal to f of x comma y. We have the formula yn plus 1 equal to y naught plus x naught to x f of x comma yn dx. Okay. So now in this problem already y of 0 equal to 0 is given. That means what? This 0 x naught y of x naught equal to y naught is given. That means x naught is 0, my y naught is 0. Okay. Now this problem is of this kind, y dash plus y equal to e raised to x. Okay. And this f of x comma y which we require is of this form. So I will just have to convert this given format into this. That means what? Dy by dx or y dash will be e raised to x minus y from this equation, and this will be my f of x comma y. So now the question is about solving till fourth order. Okay, that is fourth iteration or fourth approximation we have to solve. That means I will have to start with y1, then y2, y3 and y4. Okay, that is my first iteration, second iteration, third iteration and fourth iteration. Okay, so now if we start with the problem, let's look for y1. Y1 will be given by y naught plus x naught to x f of x comma y naught now dx. Okay, y naught is 0 from this 0 plus x naught is also 0. So 0 to x f of x comma y naught. F of x comma y naught is what? E raised to x minus y naught. E raised to x minus y naught dx. Y naught is 0. Okay. So I'll just substitute this 0 to x e raised to x minus 0 dx. Okay. So now if we see it further, if I integrate, it will be e raised to x itself from 0 to x. Now it will be what? Y1 will be equal to e raised to x as it is minus, if we substitute the lower limit 0, it will be e raised to 0 and that is 1. So this is my y1 value. Okay. Now next step is finding y2. Y2 will be given by what? Y naught plus x naught to x f of x comma y1 dx. Okay, so now y naught is 0 plus x naught till x naught is also 0, so 0 to x. F of x comma y1 is what? We have seen f of x comma y is e raised to x minus y. So f of x comma y1 will be e raised to x minus y1. So it will be what? E raised to x minus y1 dx. Now we know our y1, 0 to x e raised to x minus y1 value we have already seen from this first approximation. Okay, so it will be what? Minus e raised to x, and minus into minus will become plus 1 dx. So these things gets cancelled out. What remains is 1 dx, and if we saw integrate it, it will be x from 0 to x. Okay, so the final answer, my y2 will be equal to x. So this is my second iteration. Now I will go further for my third iteration. Y3. Y3 will be given by what? Y naught plus x naught to x f of x comma y2 dx. Okay. So now y naught is 0, x naught is 0, so therefore 0 to x f of x comma y2 will be what now? E raised to x minus y2. Okay, dx. And my y2 we have seen, y2 is my x. So e raised to x minus x dx. Now if we integrate it further, I will get e raised to x minus x square by 2 from 0 to x. If we substitute x, it will be e raised to x minus x square by 2. And if we substitute 0, it will be minus e raised to 0 will be 1 and 0 square, that term will be 0. But this one will be my y3. Okay. Now we need to find till the fourth order. The question is about finding till the fourth order. So now I'll go for the y4. Y4 will be given by what? Y naught plus x naught to x f of x comma y3 dx. Y naught is 0, x naught is 0, therefore 0 to x. F of x comma y3 will be e raised to x minus y3 dx. Okay, so now it will be 0 to x e raised to x minus y3 is given by e raised to x minus x square by 2 minus 1. So it will be what? E raised to x minus x square by 2 minus 1 dx. Okay, so if we just simplify it, 0 to x e raised to x minus e raised to x minus into minus plus x square by 2 minus into minus plus 1 dx. So e raised to x, e raised to gets cancelled out. So what remains is integral of x square by 2 plus 1. Integral of x square by 2 will be x cube by 2 into 3, 6 plus x from 0 to x. And if we substitute the limits, x cube by 6 plus x minus 0. So this one will be my y4. Okay, and we are stopping here as the question is about only finding till the fourth approximation. Now if we see the difference between this example and the previous example is that in previous example the question was about to find y of 0.1. That is what uh, once all the iterations are being done, our value needs to be substituted 0.1, x equal to 0.1 in the final answer. Now if you check this example, in this example the question does not ask you to find a value of y at any particular point. That means what? The only general formula has to be found out. Okay, so now this becomes my final answer. We need not substitute any values as it is not being asked. Okay, so this is about both kinds of Picard's problems. Once when the value is to be found at a particular point, then we have to do all the iterations, and at the final iteration we just have to substitute that particular value of x and we'll have to write the value of y. And this is the second kind of example where no value of y is asked at a particular point. Okay, so we just have to find the formula and keep. So this was about the Picard's problem. Now we will go for the Runge-Kutta method of first order. Now Runge-Kutta method of first order, we have Runge-Kutta method of second order and Runge-Kutta method of fourth order. Now this Runge-Kutta method of first order is also called as Euler's method. Okay, so the question can be anything: solve using Euler's method or solve using Runge-Kutta first order method. Okay, so anything is fine. So now this Euler's method gives us this value y of n plus 1 equal to yn plus h f of xn comma yn. Now we had seen that h is the particular distance between x0 to x1, x1 to x2 and so on. Okay, so since all these points x0, x1, x2 all are equidistant from each other. Okay, so we'll see one example. Solve dy by dx equal to x plus y with boundary conditions y equal to 1 at x equal to 0. Find the value of y at x equal to 1 with the step size h is equals to 0.2. Okay, I'll just explain this question. Dy by dx equal to x plus y. Our format is what? Dy by dx equal to f of x comma y. Okay, so from here I know my f of x comma y is x plus y. If it is not in this format, dy by dx equal to f of x comma y, as it was in the problem which we solved just now, then we will have to just convert it in this format. Okay, so now I have got f of x comma y as x plus y with boundary conditions y of 1 at x equal to 0. That means what? Y of 0 equal to 1, this is my condition. That means from here I know x naught equal to 0 and y naught equal to 1. Okay, so now this becomes my initial value. I have to find the value of at x equal to 1 and in the step size of h to be 0.2. This h, even if they don't write, they sometimes call it as step size 0.2. That is fine. That means you have to understand that it is h is equals to 0.2. So now how this goes with is I have given x naught, y naught. These both values are there with me. Okay. Then it will be what? x1, y1, x2, y2, x3, y3, and so on. These are the values which I need to find. Now x naught is 0 point, sorry, x naught is 0. Okay, for that I have got my y naught. Y naught is what? 1. Now x1 will be what? X1 will be given by x naught plus h. X naught is what? 0. H is what? 0.2. So my x1 will be 0.2. And for this I will have to find the value of y1. Then x2 is what? x1 plus h, that is 0.2 plus 0.2, that is 0.4. Then I will have to find this value, here y1, here y2. Then next will be what? x3. X3 will be what? x2 plus 0.2, that is h size, so 0.6. Then 0.8, and I need to find the final answer till x equal to 1. That means what? I will have I have x naught values, I have x1, I have x2 here, x3, x4, and x5. So basically I will have to go till y5 answers. Okay, so this is what it says. Now let's see how to solve this. First is y naught is there, y naught is 1 at x naught equal to 0, and we have f of x comma y equal to x plus y. So now y1 is what? Given by the formula y naught plus h f of x naught comma y naught. Okay, we have this formula now. Y of n plus 1 equal to y naught, sorry, we have this formula y of n plus 1 equal to yn plus h f of x n comma y n. Okay, using this formula I have got this value. So now y1 is y naught is what? 1 plus h is given to be 0.2, and f of x naught comma y naught is what? X naught plus y, x naught plus y naught. So 1 plus 0.2, x naught is my 0 plus y naught is my 1. So this gives me final answer 1 plus 0.2, that is 1.2. So y1 is my 1.2, And y1 is what? It is the that value when x is 0.1, sorry, 0.2. Okay, so this is the value when x1 is equals to 0.2. Now next step is finding y2. To find y2, it will be what? X2 will be 0.4. Okay, so now we'll be finding y2 using this y1. So formula for y2 will be what? Y1 plus h f of x1 comma y1. Okay, and y1 value I have got to be 1.2 plus h value remains constant, that is 0.2, f of x1 comma y1. X1 comma y1 is what? It will be x1 plus y1. Okay, so now if it is x1 plus y1, that means what? 1.2 plus 0.2 plus x1 was 0.2 plus y1 was 1.2. Okay, so this comes to 1.4 into 0.2, that is it comes to 1.48 final answer. Okay, that is 1.2 plus 0.28, it is 1.48. So basically this becomes my y2 value at x2 equal to 0.4. Now I need even the third value, y3. Y3 will be what? Y2 plus h of f of x2 comma y2. Now my y3 will be when x3 equal to 0.6. Okay, 0.6. So now y3 is, y2 value we have just found, y2 is 1.48, 1.48 plus h value we know 0.2, and f of x2 comma y2, f of x comma y is x plus y, so x2 plus y2. Okay, so this becomes 1.48 plus 0.2 into x2 will be 0.4 plus y2 we had just found 1.48. If you solve this, you will get y3 equal to 1.856. Okay, y3 at x3 equal to 0.6. Now my next step is to find y4. It will be at x equal to 0.8. x4 equal to 0.8. So now my y4 will be given by y3 plus h of f of x3 comma y3. Y3 we had just found 1.856 plus h will be 0.2. F of x3 comma y3 will be what? X3 plus y3. Okay, so we will just substitute 1.856 plus 0.2 into x3 was this 0.6 and y3 was 1.856. If you substitute this value and simplify, you will get y4 is equals to 2.347 at x4 equal to 0.8. You have to find these values till 3 decimal points. Okay, that will be considered as much more approximate. Now my final thing is to find y5. Okay, y5 is when x5 equal to 1. Okay, so now y5 will be given by y4 plus h into f of x4 comma y4. Y4 we had just found out 2.347 plus h remains constant, that is 0.2, f of sorry, f of x4 y4 will be x4 plus y4. X4 is that 0.8, y4 is 2.347. If you substitute all these values, you will get y5 is equals to 2.976 at x equal to 1. Okay, that was my question, to find the value of y at x equal to 1. Okay, so now I have got my value. Y of 1 is 2.976. Okay, if the question was about y of 1.2, finding 1.2, you would have done one step higher. That is what, x5 is 1. In the step of 2, x6 will be x5 plus h, right? So x5 is 1 plus h is 0.2, that is 1.2. X6, that means you have to find y6. Okay, so you will have to continue further. Okay, if it was about asking 1.4, then it would have been x7, that means you have to go till y7. Okay, now your question is just about finding y of 1, therefore you stop here and this becomes your final answer. Okay, so this is about the Runge-Kutta's first order method, or you can even call this as Euler's method.